Okay, as I am looking around the room, I notice something interesting about this problem. I see that two of our groups have the same answer, 252 Kelvin, and that is correct when you calculate. However, read the question again. What was the final temperature in degrees Celsius? So, 2/3 of the class did not answer the question. So we identify our variables, 555 milliliters for V1, T1 is 294.2 Kelvin, V2 475 mils, and T2 is our unknown. So we set this up, we multiply 475 milliliters times 294.2 Kelvin divided by 555, and we get 252 Kelvin. Now to convert this, we subtract minus 273.15, and we get negative 22 degrees Celsius because I was only allowed to keep 3 sig figs here, which would stop in the ones place. So when I subtract, I have to stop in the ones place. So we're no longer looking at the number of digits because our one group on the side that did finish this had negative 21.4. We do have to stop in the ones place. So read the problems carefully because in my opinion, this gas stuff is pretty easy, so I have to throw a few little twists in there to make sure you're paying attention. So look for little things on the test, like does it say Celsius or Kelvin? Look for what are the units in these individual gas laws, because those are the things that will be changed to make the problem a little bit more complicated, a little tougher. Now let's look at the last of the 3 small gas laws. And this is the French scientist, the law of Gay-Lussac, hyphenated name, and this is the pressure-temperature relationship. Pressure and temperature are directly proportional if we hold the volume and the amount of gas constant. So we can say pressure is proportional to temperature. In chemistry, we don't like proportionalities, so pressure is equal to the temperature times a constant, C double prime. C double prime is the Gay-Lussac constant, and C double prime is different than C prime from Charles' law, which is different from C for Boyle's law. So now we can rearrange this that pressure divided by temperature is equal to the constant C double prime. Just like the other small gases, we can rearrange this into the 2-point form. P1 over T1 is equal to C double prime. P2 over T2 is equal to C double prime. If they're equal to the same thing, they're equal to each other. So P1 over T1 equals P2 over T2, the 2-point form of the law of Gay-Lussac. So let's look at an example. What's the pressure if a gas at 15 atmospheres is cooled from 25 degrees Celsius to negative 40 Celsius when the volume is held constant? Well, just like in Charles' law, the temperature always has to be in Kelvin. So we're going to need to convert our Celsius temperatures into Kelvin before we start. So my original pressure is 15 atmospheres. My T1 is 25 degrees Celsius. I'm stopping in the ones place, so that's equal to 298 Kelvin. Does anyone need to see me do the temperature conversions anymore? Or you know to add 273.15, we stop in the ones place here. My new pressure is the unknown, and my new temperature, negative 40 degrees Celsius, is equal to 233.2 Kelvin. So we know P1 over T1 equals P2 over T2. We're trying to find our new pressure. We want that by itself. So we go ahead and rearrange. P1 T2 over T1 is equal to P2. So now we can go ahead and plug our numbers in. My original pressure, 15 atmospheres, times my new temperature, 233.2 Kelvin, divided by 298 Kelvin, my original temperature, is equal to my new pressure, P2, 11.7 atmospheres. So usually by the time we get to these problems, it's starting to feel like, oh, same old, same old. Have 4 variables in an equation, go ahead and no 3, solve for the 4th. So let's have you go ahead and do this next one at the top of page 535 with your groups on the boards.